Okay, so this part is strictly for some new developments, some newer items, and to show you that it's beyond just protons, neutrons, electrons. So this first slide is in regards to the Large Hadron Collider. I mentioned earlier that Lorenz's cyclotron ends up being the Large Hadron Collider. And this is a direct quote from Wikipedia. The Large Hadron Collider is the world's largest and most powerful particle collider, and it is the most complex experimental facility ever built. It's the largest single machine in the world. As I said before, it goes between countries. It was built by the European Organization for Nuclear Research, also known as CERN. It was built between 1998 and 2008, and over 10,000 scientists and engineers from over 100 countries worked on it. So this is Lorenz's cyclotron on steroids. And so this is what we use today to do a lot of our research. It's more than just making new elements. So I'm going to take this time and tell you, you should have your electromagnetic spectrum memorized, but if you don't, feel free to put a copy of one in your testing materials. Radio waves are your longer wavelengths. They're the ones that are in the green on the left side of this. You have radio waves. Radio waves actually have subdivisions within them, but you have radio waves, microwaves, followed by infrared, visible light, ultraviolet, X-rays, and gamma rays. We can only see visible light. That's the only spectrum we can see, but please note that your radio waves are longer waves and your gamma rays are much shorter, and we talked about penetration depth. We also talked about that we use radio waves for astronomy because they go for long distances. Gamma rays cannot travel that far, but we did use X-rays for penetrating the atom to figure out what's going on with the atom. I also mentioned about radiation, and we kept it at alpha, beta, and gamma. I do want to let you know that there is also another type called a neutron ray. And a neutron ray can get past the concrete barrier that gamma rays cannot get to. But they can be stopped with water or concrete. So, just to let you know, there's more types of radiation than what we tell you. But alpha, beta, and gamma are the ones we mainly know. This is just a chart showing you the different things that we can use radiation for. So radiation can be broken up to ionizing and non-ionizing radiation. And then that can be broken up to subdivisions. And this is showing you how they all interrelate to one another. This is a chart showing the different negative particles that we have that can form. We have the electrons, which are the ones most of us know most about. And then there are muons, pions, kaons, antiprons, and sigma hyperons. And it goes into the interactions. A weak interaction means you don't have much of attraction between them. Strong means you have a much larger attraction to them. And so I end with this. This is called the particle zoo, and this shows you, these are not the actual sizes, but there's our proton, neutron, electron. And then we also have photons, high energy. And then we have our muons, pions, neutrinos, leptons, graviton, your dark energy, your boson, your quark. Basically, we're not exactly sure what's all out there. And I will tell you that we are doing current research in this to try to understand what dark matter is, to try to understand the formation of our universe. So we in chemistry will say that our three subatomic particles are proton, neutron, electron. But understand that protons, neutrons, electrons are also made up of other things. And there are other particles in the world that we're still trying to understand to this day. So, that's it.